Welcome back to the channel, and today we have something a little bit different. As you notice, we are going to be analyzing the math in the 2004 classic movie Mean Girls. This is a movie that comes up a lot when we start learning calculus and limits, mainly due to that famous statement by Lindsay Lohan's character where she has that epiphany that the limit does not exist. We will get to looking at that question in this video today, but we're actually going to do all three questions that is shown in the Mathletes part of this classic movie. So we'll get right into it, and we'll start up at the point in the movie where the competition begins.
Good evening, ladies and gentlemen, and welcome to the Illinois High School Mathletes State Championship. Let's start the competition. Here is the first question. Twice the larger of two numbers is 3 more than 5 times the smaller, and the sum of 4 times the larger and 3 times the smaller is 71. What are North Shore?
So the quizmaster here barely gets this question off before we have a buzzer and an answer given. But luckily we have a screenshot of this question, and we can get into trying to solve it ourselves as we analyze it right here. Okay? So the question is, twice the larger of two numbers is 3 more than 5 times the smaller, and the sum of 4 times the larger and 3 times the smaller is 71. And we're tasked to find out what those two numbers are. So this is a pretty standard kind of algebra question, and if you are in either middle school or high school and taking those algebra classes, you'll know we always begin with defining our variables. Okay, so we're going to have two variables, x and y, and we're going to write out in words what they are. So we're going to say that x is the smaller of the two numbers, so this is our smaller number, and y will be our larger number as it refers to in the text. Okay? So we'll start breaking this text down. It says twice the larger of the two numbers. So we're looking to make equations here. So twice the larger, that would be 2y, is, and then is a kind of math word for equals. So is 3 more, so something plus 3 more than 5 times the smaller number. Okay, the smaller number was x, so 5 times the smaller number, that would be 5x. Okay, so we've made ourselves one equation here that has two unknowns in it. Okay? And again, if you remember back to high school or middle school, you'll know that in order to solve an equation with two unknowns, you need at least two equations. So if we keep reading this sentence, we get some more information. That information is the sum of 4 times the larger and 3 times the smaller. Okay? So let's put that into an equation. 4 times the larger, that's 4y, and then we're told sum, so we add. 3 times the smaller is 3x. And again, we've got that magic word is 71. So we know this equals 71. So here is our second equation. And what we've formed here is what's called a system of linear equations. These are commonly solved again and again and again in high school and middle school. So from here, we can approach this with either substitution or elimination. I'm going to go with an elimination approach. I'm actually going to take the first equation and just rearrange it a little bit. I'm going to get both the variables on one side. So that would be 5x minus 2y equals negative 3. So just subtracting 2y and subtracting 3x. And then the second equation, I'm just going to rewrite it with the x's first and the y's second. So just reordering some of the algebra on the left. Okay? I'll call these equations 3 and 4. Okay? Now, in order for this elimination approach to work, I need one of the variables to eliminate, so when I add them together, they zero out. Right? The easiest way to do that here will be to take this first equation and multiply it all by 2, which will get those y's up to negative 4y and cancel nicely with equation 4. So I have 10x minus 4y equals negative 6. We'll call this equation 5. And now we're set up for our elimination. If we add equations 4 and 5, we're going to get 13x. 3x plus 10x will give us that 13x. The 4y and the 4y will eliminate or cancel out. And then we've got 71 minus 6, which should give us 65. Simple solve for this variable now. Divide by 13, which should give us x equals 5. Now, if we go back to the question, it did ask us what were the two numbers. We have one of the numbers. We know one of the numbers is 5. In order to find the remaining one, we just need to substitute it back in to one of our original equations. We'll go with the first one. So we'll take 2y equals 5 times 5 plus 3, which should give us 2y equaling 28. Therefore, y equals 14. So our two numbers solving a system of linear equations should be 5 and 14 here. And if we return back to our video, we'll see if this person who buzzed in was correct.
Sure.
14 and 5.
That is correct. Question number 2.
All right, so the quizmaster confirms his correct answer. He says 14 and 5, clearly matching what we were able to obtain with our system of linear equations. Okay? Now, what's most impressive here is the time he answers that in. That is a very, very quick solution. This guy's barely finished reading the question, and this gentleman here has already solved it and got it right. But it's not a difficult math problem if you've practiced and you're ready to go like these guys are. All right, now we transition into the next question in the competition.
Find an odd 3-digit number whose digits add up to 12. The digits are all different, and the difference between the first two digits equals the difference between Marymount.
741.
Correct.
Shoot.
So this question, the quizmaster doesn't even finish asking it, and this guy's already got the correct answer. So let's take that a little slower and break down the information we were given and see if we can figure out what the full question might have been. Okay? So the question was, find an odd 3-digit number whose digits add up to 12. The digits are all different, and the difference between the first two digits equals the difference between, and that's where the buzzer goes off. And the gentleman gives this answer of 741. Okay, so if we take those digits, 7, 4, 1, we take the last piece of information we were able to hear, the difference between the first two digits. So the difference between 7 and 4, that's a difference of 3, or in this case, subtracting 3. And we notice in his correct answer between 4 and 1, that's also a difference of 3. Okay, so when his answer is confirmed to be correct, 741, I think we can safely assume that this was the full question. Okay? So it was find an odd 3-digit number whose digits add up to 12. The digits are all different, and the difference between the first two digits equals the difference between the last two digits. Okay? Now, that's an unbelievably short amount of time for him to solve that, but let's try and get into how he might possibly have done that. Okay? So we're going to model this out as 3 digits, so we're going to think about 3 blank spaces, okay? And we know that all of these are different. Okay, we'll give a variable for each digit, just like we did in the previous question. Okay, so we'll say that x is the first digit, the hundredths. Okay? We'll say that y is the second digit. That's going to be the tenths, and then z, that'll be the third digit, and that's the units. Okay, and if we break this question down, it says find an odd 3-digit number. So first thing we know is that this is odd. Okay. So we know that z has to be odd. Okay, in order for a number to be odd, that last digit must also, not be divisible by 2, must not be even. So we know that z is odd. Okay, we're also told that these digits add up to 12. Okay, so that can give us our first equation here: x plus y plus z equals 12. Okay? Continuing reading the question, we've got all the digits are different. So we know that x does not equal y and does not equal z. They're all different. Okay? And here we get the final pieces of information, one that's given and one that we've kind of implied from seeing that correct answer. It's that the difference between the first two digits, so when we hear difference, we think subtraction. Okay? So we've got x minus y is equal to the difference between the last two digits. Okay? The difference between the last two digits, that would be y minus z. Okay? So here we have 3 unknowns and only 2 equations. Okay? So technically this is an impossible situation to solve for a unique solution. However, the question is actually worded with an important detail. It just says find an odd 3-digit integer. Okay? So there may be multiple solutions, and we're just tasked to find one, which, as we saw, this guy is able to do correctly with his 741. So we're going to try and find all the possible solutions and hopefully see that his answer is in that set. Okay? So there is a bit of algebra we can do to simplify. Okay, we can go ahead and take this equation 2, and we can actually isolate one of the variables, which is the y. So if we add y to both sides, and we add z to both sides as well, we end up with x plus z is equal to 2y. And if we take this, we'll call it equation 3. If we substitute this equation 3 into equation 1, we get the following. So we're essentially going to replace the x and the z with 2y. Okay, let me take that a little bit slower. So I'll rewrite equation 1, just moving where the z is in that algebra, and then essentially I'm doing a substitution where I can replace this x plus z with 2y. So this gives us 2y plus y equals 12. This is actually a one variable equation. 3y equals 12 tells us y equals 4. So we know the middle number, or the middle digit in our number, must be a 4. Okay, now we still don't know the digits on either side, but we know they must be equally spaced from 4, and this last digit must be odd. Okay, so if we play around a little bit here, we can list out the possible combinations. Okay? So we're looking for digits with a 4 in the middle that are odd. Okay? So let's just start substituting odd numbers in this last spot over here on the far right. Okay? The first odd number we could do, that would be a 1. Well, the difference between 1 and 4, that's a 3, which means the difference between 4 and the first digit must also be 3. So that would give us this number that he gives out as his answer, 741. But are there other answers? Well, let's keep going and see. Again, 4 has to go in the middle, and we need an odd number at the end. Okay? Well, an odd number at the end, the next odd number would be 3. If we put a 3 there, we would be adding 1. This last digit would have to be a 5. Okay? So we have 543 as a possible solution. Now, are all the digits different? Yes. Do they all add up to 12? Well, 5 plus 4 is 9, plus 3, that's 12. So I believe 543 would also have been a good solution. And we can keep going. Okay? We can keep going using odd digits in that last spot. So the next odd digit would be 5. If we put a 5 there, we know this is going down by 1. So we would get the same number in reverse. An answer of 345 also meets those criteria. One more, next odd number would be a 7. So we could go 4 in the middle, 7 at the back, obviously leading us with minus 3 here, meaning our digit at the front would have to be that 1 again. So again, just the answer he gave, but in reverse, 147. So far we have 4 correct answers. Let's see if we have any more. We'll come over here and do this. A 4 here, we could go to a 9 here. But the problem with using a 9 is 4 plus 9 is already 13, and we know all 3 digits have to equal 12. So this is not a feasible answer. So while it says find an odd 3-digit number, I believe we have 4 answers: 7, 4, 1, 5, 4, 3, 3, 4, 5, and then finally 1, 4, 7. Those would be our 4 answers that solve this problem. All right, back to the video and the last tiebreaker question.
Making fun of Carolyn Kraft wouldn't stop her from beating me in this contest.
Contestants, find the limit of this equation.
Calling somebody else fat won't make you any skinnier. Calling someone stupid doesn't make you any smarter. And ruining Regina George's life definitely didn't make me any happier. All you can do in life is try to solve the problem in front of you.
The limit is -1.
Oh, crap. I lost.
That answer is incorrect. Now, we are in a sudden death. If Miss Heron can answer this problem correctly, we have a winner.
Limits. Why couldn't I remember anything about limits? Limits. That was the week Aaron got his haircut. Oh God, he looks so cute. Okay, focus, Katie. What was on the board behind Aaron's head? If the limit never approaches anything, the limit does not exist. The limit does not exist!
Our new state champions, the North Shore Mathletes.
So this is the part most people refer to in the movie, this question about limits. So we have it blown up here on our whiteboard. They are asked to find the value of this equation by the quizmaster, which is actually a slight incorrect mathematical phrasing in that there's no equals in this, so it's technically not an equation. You should really phrase that as evaluate the limit of this expression if it exists. If you haven't studied any calculus with limits, we're going to do a quick bit of background here. If you do already know limits, this might serve as a review. And then we'll come back to this problem when we feel more equipped to talk about limits. Okay? So limits deal with what happens as a graph approaches a certain value, not what actually happens at that value. So here is a wacky graph of g of x, and we're asked to evaluate a bunch of things about this graph, including some limits. Okay, so we'll go through and interpret these as to what they mean and what the terminology is saying. Okay? So part A tells us the limit as x approaches 2, and it has this little negative sign kind of in the exponent of the 2. Okay? What this means is we are approaching 2 from the left side. Okay? We're coming at it from numbers just smaller than 2, meaning on the left. We use a negative sign because that's the left side of our number line. Okay? So essentially we are on this graph. We're going to x equals 2, which is right here. Okay? We're going to go slightly to the left of 2. So maybe just a fraction over to the left, right here, where the red arrow is. We're going to go up and find the graph. Okay, we're right here on the graph. And we're going to go back towards 2 from the left-hand side. Okay? So we're tracking on this straight piece of graph, okay, approaching 2 from the left, and we're interested in what y value is this function going towards. And in this case, it's going to 4. And you might be saying, but it doesn't actually get to 4. There's an open circle there. Open circles are undefined. Well, you'd be correct. But again, limit is a tool that looks at what happens as a graph approaches a certain value, not what actually happens there. We have a tool for finding out what happens there, that is function evaluations. Limits are a tool for when we get really, really close. So carrying on with part B, we have the same thing, but with this little plus, which just tells us we need to be on the right of x equals 2. So if we come to the right side with this purple arrow, we can go up, find the graph, and again, come back towards 2 from that right side, from the positive side of 2. Okay? We're interested in the y value here, and we can see here that the y value is 1. So this second part B, this has a y value of 1. Part C looks very similar, but it doesn't have the plus or minus. So what does that mean? That means we're dealing with a two-sided or a general limit here. Okay? Well, in order for a two-sided limit to exist, the left and the right side must be coming together. They must be coming to the same value. And as we've just seen in parts A and parts B, they're not coming to the same value. One's going to 4 and one's going to 1. So this is the scenario where we say this limit does not exist. Okay? And if you've already kind of made the connection to the video, that's what's going on in her problem. That's what she's cleverly figured out in her mind is happening with her graph. Just to carry on our understanding here, we'll blitz through these next couple. Limit as x approaches 5 from the left. So we go to 5 here. Again, slightly to the left, this green arrow. We go up, we find the function, come back up 5 from that left side, find the y value here. The y value here is 3. So this limit has a value of 3. In part E, very similar, but we're coming from the right. So we're on the right side of 5 right here. We're on the same piece of graph, but on the other side, we're coming back towards that open circle. We have the same y value right here of 3. So part F is where things get interesting, where we have another two-sided limit. Okay? And again, we need those two pieces to come together. We've just seen they do come together in parts E and D. So this limit actually exists. This two-sided limit does come together and equal 3. So that's a situation where a limit does exist. Okay? Part C, it did not exist because the two pieces of graph didn't connect. In part F, they did connect. Part G asks us for the limit as x approaches 5. Oh, sorry, not the limit. Part G is just g of 5. That's the function value at 5. Okay? Well, the function value at 5 is this big closed circle highlighted in pink. And we could see that the y value there is 2, so this just drives home this idea that limits don't care about what happens at the number they're approaching. They care about the approaching part, not the destination. Our final question is a limit to infinity, so the limit as x approaches infinity. So that's a way to describe what's happening on this far right side of the graph. Okay, as x goes to infinity, where is the y values of this graph going? Okay, so you can see the little arrow on the end of the g of x function. It's indicating this graph's going to keep going down. So this limit as x approaches infinity, the graph of g of x will go to negative infinity because that graph is going down. Okay? That's an important idea, that a limit can go to infinity even though infinity is not actually a number, because again, we're just saying what it's approaching. So with all that in mind, we can return to the problem in the movie, which is this more complicated limit right here. So the limit as x approaches 0 of natural log 1 minus x minus sine x over 1 minus cosine squared x. Okay? And you saw in that clip, she thinks back to what she learned about limits, and this is a screenshot of what she remembers from that class. And we can see in this video that she's doing some one-sided limits. We see the little limit as x approaches 0 positive there. That's indicating a one-sided limit. Okay? And we even see, it's tough to tell, but over here there's some one-sided limits as well. Okay? And they're clearly looking at a graph of a rational function, so something like y equals 1 over x, and that asymptotic behavior on either side of x equals 0, and then out to positive infinity, and out to x going to negative infinity. So this is what she's remembering with this infinite limits. So what do we need to do? If we're going to take a non-calculus approach, we're going to look at a graph of this function that she's given. So we have that all set up for us right here. And in Desmos, I have graphed this function. And she is interested in the limit as x approaches 0. So she is interested in what is happening around x equals 0. Okay, so it's pretty clear to see that on either side of 0, she's got one piece of graph going up to positive infinity and one piece of graph going down to negative infinity. Let's just go ahead and get a little screen grab of this, and we'll bring it into our software. Here we go. So taking a look at this Desmos graph, we can analyze this limit without any calculus knowledge. So here's that screenshot we're just looking at. Okay? If we take a left-sided and a right-sided limit, okay, limit as x approaches 0 from the left side, I'll write out her function again. It's ln 1 minus x minus sine x over 1 minus cosine squared x. Okay? We're going to do a right-sided and a left-sided limit. I'll write this one out again. We can see that when we come from the left side, when we're doing the left-sided limit, okay, that's this first one with the little minus. Let me do that in green. Okay. We're on this piece of graph right here, slightly to the left of 0. We're looking at this piece, which is clearly asymptoting up to positive infinity. So we would say that that first limit has a value of positive infinity. Okay. Her other limit from the right, which is the second one with the 0 plus, okay, she's on this piece of graph down here. Okay. And again, it's clearly asymptoting towards x equals 0, but this time it's dive bombing down to negative infinity. So her second limit from the other side would be negative infinity. And as we just saw in the previous example, if these two things do not equal, then her two-sided limit, her limit as x approaches 0, which was the question she was asked in the competition, okay, this limit will not exist. Okay, so this is where she's making the statement does not exist. Now, there are calculus approaches to take to get to this conclusion, but we're trying to do this in a non-calculus way so we can get a wider audience understanding what's going on here. Okay? So this is the revelation she makes. This is how she wins the competition for her team. And hopefully you've enjoyed this kind of fun look through that classic movie. If you want to see the more calculus-based explanation of this limit problem, I'll be happy to make a video on that. Just go ahead and let me know in the comments. And thank you for watching.